Okay, we can ask to sketch the graphs of these two functions. First of all, we just read off from the form of the equation that the slope is 2 and the y-intercept's at 0, -3. And that's sufficient to begin to sketch the graph. We'll put y equals -3 down here. Now, what do we mean by a slope of 2? It means every time we go over 1 unit, we go up 2. Okay, means, so for example, if we go over 1 unit to x equals 1, then we're going to have to go up 2 units, which is going to put us at y equals -1. So that this little triangle here if we enlarge it, so we can label it as a rise of 2 and a run of 1, so that the slope, which is rise divided by run, equals 2 over 1 equals 2. Meaning at this point would be the point 1, -1. So this is a y-intercept. It's at 0, -3. Again, this is the y-intercept, this is the slope. So there's your y-intercept over here. This point is, well, it's where the x equals 1 line meets the y equals -1 line. So this point is at the point, or this is at the point, this is the point 1, -1. And you can sketch a straight line through those 2 points. If you want to sketch a little better one, you could like go over to, oh, say x equals 3. Now, if this is x equals 1, you go over a couple more units and you get x equals 3. So let's say 1, 2, 3. 3 should have actually been a little further out that way. So I didn't draw it with great precision. But then we go up. Oh, matter of fact, let me see if I can put x equals 3. Let's see if I can locate that a little more. You understand what I'm doing? This is 1. Here's another one. Here's another one. So I'm saying x equals 3 should be about here. Okay. Then if I go over 2, I've got to go up 4 in order for the slope to be 2. So what's this line going to be? Well, this is at y equals -1. If I go up 4 units, what am I going to be at? Can you write that down? Tell me y equals what? Right. Go up 4 units from y equals -1. Okay, so we can see it pretty easily. We go from y equals -1 and go 4 units higher than we're going to be at y equals 3. And to get that, you can just see that, you go up 1 unit, you're here, you got to go up 3 more, that's going to put you at y equals 3. We want to be able to navigate the coordinate plane well enough to do this. There are other ways to graph it, and we'll look at a couple of other ways. The other thing we could do, of course, we just do a formal calculation. -1 plus 4 gives you 3. In any case, so we go up here, oops, Now, that doesn't look quite straight because I didn't have my scale right. So I'm gonna say, well, actually, the graph is probably about like so. Kind of ignore that little blip there. So it's not real precisely drawn. You understand that if we've got this, we can always draw a triangle where the rise divided by the run is equal to this number. It's not equal to. And that's of course true for this triangle as well. The rise is 4, the run is 2. So we go over any number of units here and then up the right number of units and we'll get a second point. We can always graph the intercept when we're in this form. And then we can always go over however far we want and up the according. Up through the according rise, okay. Okay, so you want to understand this, just because it gives you a better picture of what's going on in the coordinate plane. And I also kind of advocate that you don't start your graph like this. And now you're doing good evenly spaced marks. I'd say avoid this. I like this much better because when you mark it off and you mark, let's say 10 points on each side and 10 points above and 10 points below, then you need a point that's 30 units out that way. You don't have room in your paper. So you've committed yourself to a scale that isn't going to work. Now, you get around that by thinking through where your points are going to be, and then you mark your graph off accordingly, okay? But I like the idea of just doing an unlabeled graph and saying, okay, I'm going to put x equals 1 here, and I'm going to put y equals -3 here. And then you go from there. And I'll make estimates because it gives you a better picture. Now, either way is okay. But if you do this, you're doing extra work and you're not seeing as much. You see more if you do this. Still, get you the right graph. On a test, you're going to get credit for it. Then you will know something. Try to know as much as you can about this. Now, another one. Get the y-intercept when x equals 0 and the x-intercept when y equals 0. Well, if x equals 0, y equals 2 times 0 minus 3, which is -3. Of course, we just read that all for this form of the graph. But we don't always have the thing in slope-intercept form, so you can't always just read it off. You can always, though, let x equals 0 and find the y-intercept. And then, and it's not just linear functions. You can do this for most of the graphs that we're going to be looking at in the course. And you want to do this. You always want to see what happens when x equals 0. And you always want to see what happens when y is 0. Now, what happens when x equals 0 is usually pretty easy. What happens when y equals 0? Well, it gets a little more complicated because you've got to solve an equation. Okay, so the x-intercept from y equals 0, well, we let y equal 0. Our equation becomes 0 equals 2x minus 3. Y becomes 0 and 2x minus 3 is still what it is. And we solve this by adding 3 to both sides. -3 plus 3 gives us 0. 0 plus 3 is 3. And we're going to get 2x equals 3. So let's rewrite that. 2x equals 3. What do we do to both sides of this equation to solve for x? We don't shortcut it. We write out all the steps. We don't write out what we think it ought to look like. we write out what it is. Okay, so we divide both sides by 2. Then the 2 divides the 2, leaving us x. And we get 3/2. At that point, we can sketch a graph. Okay. If we've done this, now I've got to come way over here. But, okay. -3/2. And the y-intercept is -3. Now, if you mark this thing off in 10 units here, you're not going to be very accurate. Like, where's 3/2? Well, that's 1/2, 1, 1.5, right? 3/2 is 1.5. So your x-intercept would be like here, and your y-intercept would be at -3. So you have this, okay? And that wouldn't be bad. But I'm just going to mark where I think x equals 1. I'll put x equals 1 where I want it. And then, of course, x equals 2. And I like using these dotted lines because I can label the x coordinates out of the way, okay? If I put them here, then chances are my line's going to go through one of my numbers. Also, this reinforces what we mean by vertical line. And then if I say, okay, y equals -3 is down here. Then here's my y-intercept. And here's my x-intercept. And I can even say, okay, this line right here is x equals 3/2. And now I've got everything documented and labeled. There's my x-intercept. There's my y-intercept. There's my straight line. Okay. We should be able to do it either way. And of course, the problems you've done have dealt with it in both ways. Okay. Well, let's look at this. Y equals -1/2 x plus 4. Now, there's a little bit of a curveball there. I've got a negative number and I've got fractions. People have a little more trouble with fractions. We would hope, simply because you haven't had to do a lot of fractions in your previous courses. But you got to do them here. So you got to be aware of that. Okay, so let's take y equals -1/2 x plus 3. Imitate what I did and find the intercepts. Okay. First of all, it puts you in for y, and you know, everybody knows, you subtract 3 on both sides. And you get -3 equals -1/2 x. Now we usually want to look at it with the x on the left, but it doesn't hurt to have it on the right. If you're comfortable with that, it's fine. But I'll put it on the left because most people are going to like it better. Okay. Now, what do we do here? Now, here's where we run into real problems. And here's where we always run into problems because people have forgotten how to do fractions. We have assignments in this course that are meant to review doing fractions. But again, I find that most students don't retain it because I didn't make the assignment long. Okay, I could have given you 100 problems. And my point is, I'm not going to give you 100 problems because some people don't need 100 problems. And if I did give you 100 problems, half the class would have a mental breakdown. Okay? Wouldn't handle it, they couldn't handle it, and that's simply fact. So I can't give you 100 problems, even though in fifth grade you're given 100 problems. And the curriculum is terrible at fractions, so you have an excuse, but you got to get over it. You need drill and practice on fractions. Now, at a lecture, let's solve this thing. Okay, we tried several different things. Okay, tried multiplying both sides by 3. Didn't work. Tried a variety of things. But the one thing that does work, what would you multiply by 1/2? -1/2 to get 1. Because that's what you want. You want just x. You want a 1x here. So you want to multiply this by something that gives you 1. And the answer is, well, it's -2. Then you multiply on both sides. Okay, now to multiply, most people are going to need to have 2 fractions to remind them how to multiply fractions. But again, at this stage of the course, people don't remember how to multiply fractions. And it's the easiest thing you can do. You multiply the numerators and you multiply the denominators. So you get -2 times 1 over 1 times -2 times x equals -2 times 3. Everybody's good there. That's 6, okay? Which means that -2 over -2 x equals 6. And -2 over -2 is just 1x equals 6. So x equals 6. So now the y-intercept and the x-intercept. Occurs at point 0.06. So now we know something about this graph. Decide where you want x equals 6, draw a vertical line, label it x equals 6. That's a point on the graph. Now the y-intercept and you want to write this out. When you work these problems, you write y-intercept when x equals 0 so that you keep reinforcing, so you're going to remember this. Okay? So if x equals 0, you get y equals -1/2 of 0 plus 3. Now, this is slope-intercept form, so it's clear that this is slope and this is intercept. Okay, so you could know just from slope-intercept form that this is a y-intercept. I want you to do this because you're going to have to do this with other kinds of equations where you can't read off the intercept, including linear equations that aren't in slope-intercept form. So we have to reinforce this idea because this is something that 2/3 of the way through the course, people still will not remember. We want to remember it now. Okay, so, and I didn't write it up here. I'll write it small y-intercept when x equals 0. X-intercept when y equals 0. So you can't probably read that from the R, but just to be consistent with what I'm saying, write it out and then say, okay, if y equals 0, which is a condition for your x-intercept, then we'll get this equation that we can solve for x. And fractions are a fact of life. Okay. Okay, so well, y equals 3 then, because 1/2 of 0 is 0. Let's just do 2 steps, 0 plus 3. So y equals 3. So now we have the point where x equals 0 and y equals 3. This is the point where y equals 0 and x equals 6. So I'll label it 6, 0. And I'll label this point, well, I'm gonna put y equals 3 here. And that's more or less on scale, to scale with this, not quite. But this point then is 0, 3. And now I can skip that on. Now, we also want to label our graph. So this is the graph of y equals -1/2 x plus 3. You can then, if you need to, proceed to divide the interval from here to here up into 6 equal parts. Divide this interval into 3 equal parts. So, right there is halfway. That would be 3. Divide that twice. This distance is 3. Divide that twice. Then you got this divided up into 6 equal increments. And then you can draw equal increments out here if you need to. Okay. I wouldn't start by doing this because you never know how far that's going to be out there. And you never know how far that's going to be out there. So before you start like this, and again, I'm saying this for the 16th time today, probably, it reinforces these vertical and horizontal lines. It reinforces what projections are. It gives you a better picture of what's going on in the plane to do it the way I've drawn it. Don't require this, but I think you'll do better in this course and in subsequent courses if you get this picture. So I really recommend you use it. Okay. Well, how else could we do this? Again, we have y equals -1/2 x plus 3. I don't know what equation I was just working on. Oh, yeah, I guess we're still working on the first equation. But no, we weren't. So what am I doing? I've lost track of the boards. I want to refer to what I've just done and it wasn't there. So excuse me for confusing myself. Okay. So right here is our graph of this function. How else could we have gotten this graph? We get the y-intercept at 0, 3. Well, that's the same as it is for this. Yeah, a minute ago, I wanted to point to this, it wasn't there, so anyhow, okay. So for y-intercept is at 0, 3. And we're not looking at this because we pretend we haven't ever done this. We're doing this independently. So I'm going to be able to put the line y equals 3 here and the point 0, 3. Now, the slope is -1/2. Okay, what does the slope of -1/2 look like? I'm going to draw a triangle here. If we go over 1 unit, got to go down 1/2 of a unit. Okay. Now, what if I wanted to do a slope of -1/2 by moving over 4 units? Then how far up or down would I have to move in order to have a triangle whose rise divided by run is -1/2? I'm gonna do a synopsis here because I screwed up and didn't record, and I kind of like the way the dialogue went, but, okay. Again, we've obtained this graph just by finding intercepts. Now we're gonna do the graph with the same function, but we're gonna do it using slope triangles. So just synopsis, okay, you see it all here, and you see all this confusing stuff on the board, but it's very similar to what I did before. First of all, the y-intercept is at 0, 3, because this is slope intercept form. It's a y equals mx plus b. B is 3, m is -1/2. Okay. So we say, okay, slope -1/2. Y-intercept is your 3. And the -1/2 is your slope. The 3 is your y-intercept. So the y-intercept occurs at the point 0, 3, because x is 0. And of course, we reinforce that over here. Well, that's exactly what we got over here. But over here, we figured it out. As we will need to do when we do equations that aren't linear. Say, okay, if y equals 0, we solve for x. That's how we did it here. We got this. Here, we just read it. And there it is. So there's the y-intercept. Okay. Well, we sketched horizontal line y equals 3. It's not absolutely necessary, but I really want people to do it because you're going to understand the coordinate plane better if you keep doing this, and it doesn't take long to write a dotted line and label it. And notice I didn't mark off the units on my x-axis because most of the time when I'm doing a graph, I don't know how many units I'm going to need. I don't know where my points are going to be. Okay, so I just sketch a set of coordinate axes and start figuring things out and put some lines on it to label the important points. Okay, or the important characteristics. Okay, so anyhow, we've got this point. Now we want a slope of -1/2. Well, here's a picture of slope -1/2. If we move over 1, we move down negative, well, we move vertically -1/2. Horizontal move of 1, vertical move of -1/2. And that gives us a slope, which is rise over run. Rise would be -1/2, the run would be 1, -1/2 divided by 1 is -1/2. So there's a picture. And we could have gone over 1 unit and down 1/2 unit and marked a point here and drawn the line. I like to go a little further because I don't want my points too close together. If they're too close together, it's real easy to be off by a little bit and not notice it. Further apart they are, the easier it is to get everything right. So I'm going to say, oh, that's 3 here. I'm going to go 4 units. I'd have gone further, but I didn't have room on the board. Okay, so I go over 4 units. Now what I want is, I want to figure how far I go up or down. Okay, well, if I go over 4 units, then that's my run. Now rise over run is supposed to be -1/2. We'll let the run be 4. That's what I've done here. So we get what? If the run is 4, we got rise over 4 equals -1/2. Okay. Then I ask, okay, so what number do I need here so that this fraction gives me -1/2? And very quickly got the answer. Okay, it's -2. That was good. Okay, and then we just kind of verify that. You know, what I wrote over here first was what number over 4 gives us -1/2. And that's why I got a quick answer. We got -2 over 4 equals -1/2. So now I've got this picture. -2 would be a little longer than that. But right there we have, again, slope -1/2. And we use this triangle up here. That's a little smaller up here because I chose 4 units to be this small. Okay, to put it in kind of the same scale as 3, so we get a realistic looking graph. But we did a run of 4 and rise of -2 from this point, and we've got a new point, and there it is. Okay. And of course, then we labeled this point. If we go over 4, the x coordinate goes from 0 to 4. This is 4 units here. So this is the line x equals 4, 4 units from here to here. Puts us at x equals 4. And we go down 2 units from a point where y is 3. That's going to put us at y equals 1. So we get to point 4, 1. And then we look back at this graph and say, yeah, that looks pretty consistent. So let's extend it. Let's estimate where that is. Well, if this is 4, let's see, 2 would be about that much, and 2 more than 4 would be about 6. So maybe x equals 6 there. Well, it had better be, because that's where it is. That's what it was when we did it this way. That's where it is when we did it this way. So we have 2 ways of doing that graph. All right. So again, we get big hangups on fractions. We need to practice more fractions. And almost everybody does, including people starting pre-calculus. Okay, I got to point 25, and I'm going to want a line through this point with a slope of -2. Can you give me another point on the graph? Can you find another point so that the triangle from this point to this point, the triangle like the ones I'm making here, gives you a slope of -2? I'll be happy with any point. Okay, so what we did, and we just kind of did this, and more or less one fact with everybody. Here's the line x equals 2 because the x coordinate here is 2. Okay, now I asked everybody to draw a line, so somebody drew a line of length 6. And that looks like about 6. There's 2, so there's 2, 4, 6. It can actually be a little longer than that. So there's 6, maybe. Probably should even be a little longer, maybe out to about there. But we're not trying to win awards for our accuracy. We're just trying to see what's going on. So if we go out to 6, then we want to draw a triangle like we did over here. So we kind of make ourselves a little note. Run equals 6, slope equals -2. So rise over run equals -2. Rise over 6 equals -2. What number do you divide by 6 to get -2? Well, you came up with this number, -12 over 6 equals -2. Now you could always take this to be an equation and multiply both sides by 6. You get -2 times 6 and you get the rise, okay? So you treat this as an equation, multiply both sides by 6, because you might have to do that if the numbers are a little nasty. If this number is -1.7, that's probably what you're going to do, because you're not going to come out with -12 in your head, right? Or you're not going to come out with the right number in your head if that's a bad number. That's a more complicated number. Anyhow, so rise is -12. I think we understood that pretty well. Okay, well, how do we draw that? Well, you got the triangle, you got an arrow here, and then at the head of that arrow, you draw the arrow for the rise. You got to draw a rise, and the rise got to go down here pretty far because, well, let's orient ourselves. We got this line here, y equals 5. Okay, that means from this line down to the x-axis is 5 units everywhere. Now it looks like it's getting further apart because I've been doing it very good x-axis. It's kind of going downhill, but this line represents a line that's always 5 units above the x-axis, whether my picture looks like it or not. So we've got to go down far enough to get -12. So how far do we go? Well, we're going to have to come down here to y equals something, so that from this line up to this line is 12 units. So if from here to here is 12, here's 5 of that distance, you gotta have 7 here. So y is -7. We conclude then that this point here should have coordinates. Okay, well, y coordinate is going to be -7. What's the x coordinate? Well, how far is it the y-axis to this line? That's what the x coordinate is, and we got to get, pretty good at that reasoning to really understand the coordinate plane. Okay, so well, from this vertical line, where x equals 2 out to the vertical line here, it's got to be 6 units because it's 6 units from here to here. So these lines are parallel because they're both vertical. So got to be 6 units everywhere, and meaning that from x equals 2 out to this line is 6 units, but this line's already 2 units from the y-axis. So x equals 2 plus 6 is 8. So now our point is 8, -7. Now we draw the line through this point. And we could figure out what the y-intercept is. Okay. If we have the graph up a little further, we got a run of 2. Okay. From this point over to here, actually the run is -2. What should the rise be? Well, it should be 4. So the y-intercept should be 9. So the graph is -2x plus 9. We don't have time to do that today. There's a formula you learn in open math for finding the equation here, and it doesn't involve all this reasoning. But today I wanted to emphasize the kind of reasoning we have to do in the plane to understand what the equations are telling us. Okay. Now you're going to just use the equation, and it's pretty easy to do. But make sure you kind of draw these pictures whenever you can. Make sense of it. Make as much sense of it as you can, because pre-calculus basically takes place in the coordinate plane. You want to understand it. Okay.